Okay, have you ever really stopped to think about this? The same exact idea that powers your phone is also running the traffic lights on your street? I know, it sounds kind of crazy, but it's totally true. So today, we're going to pull back the curtain on that single powerful concept, and I'll show you how understanding it is, well, it's like unlocking a modern-day superpower. Let's dive in. I mean, really think about it for a sec. You've got your smartphone, right? Fits in your pocket. Then you've got a 3D printer, literally building things from nothing. And then there are the traffic lights, managing the chaos of a whole city. On the surface, they couldn't be more different, could they? But here's the thing. They all share the exact same fundamental DNA.
And what is that DNA? Well, it's pretty simple. They're all computers. That's it. They just have different jobs, different personalities, you could say. And once you really get that single idea, I promise, the whole world of technology just clicks. It starts to make so much more sense. Okay, so a superpower? Am I exaggerating? Not at all. Because let's be honest, in the world we live in today, understanding how tech works isn't just a nice-to-have, it's essential. And I'm not kidding. It doesn't matter what you do. Maybe you want to design the next big app. Or maybe you're in healthcare, pioneering new medical tools. Maybe you're trying to solve huge problems like climate change. Whatever it is, knowing how computers think gives you this massive advantage. It's really become the universal language for solving problems.
So what is this secret language, this universal blueprint? Well, it turns out that every single computer, and I mean everything from a massive supercomputer all the way down to your microwave, is built on the exact same simple model.
So first, let's break it down. You can pretty much split the entire world of computers into two big buckets. On one side, you have your general-purpose computers. These are the chameleons, right? Your laptop, your smartphone, they can be anything. One minute you're playing a game, the next you're crunching numbers in a spreadsheet. It all depends on the software. Then on the other side, you've got your special-purpose computers. These guys are specialists. They're designed to do one thing and do it perfectly. Think about your microwave, or the little computer running your car's engine.
But here's the key. At the heart of both of these types, there's one single blueprint. It's called the input-process-output model. Now, I know that sounds super technical, but stick with me because it's actually incredibly simple. This basic three-step dance is the foundation for absolutely everything a computer does.
And the sequence never changes. It's always the same three steps. First, you've got input. This is just the computer getting some information, a command, some data, whatever. Second, process. This is the brainy part, right? The computer works on that info, it does the thinking, the calculating, and then finally, you get the output. That's the result, something you can see or hear or even feel. Okay, let's make this real with an example you use every day. Let's talk about your microwave. Seriously. So the input, that's you, pushing the buttons. You tell it 90 seconds on high. The process? Well, that's the microwave doing its thing, heating up your food for exactly that amount of time. And the output? That's the beep and, of course, your hot burrito. See? Input, process, output. That's it. And that exact same logic, that same sequence is happening in millions of devices all around you all the time.
Okay, so we've got the blueprint down. That's the how. But now let's get to the really powerful stuff. Learning to think like a computer so you can solve really complex problems.
There's a name for this, and it's called computational thinking. And don't worry, this isn't about becoming a robot, not at all. It's about looking at a big, messy, complicated, real-world problem and breaking it down into logical steps. Steps that a computer could understand, sure, but also steps that your brain can tackle one at a time. It's really just a framework for getting clarity.
And the very first step, the absolute first thing you do is something called decomposition. Again, it's a fancy word for a really simple idea. It just means taking a huge, overwhelming problem and breaking it into smaller, manageable chunks. You know, you don't eat a whole pizza in one bite, right? You slice it up. Same idea here. You're not going to build a whole video game at once. You start by figuring out how to make one character move. You're not going to write a whole book. You start with the first sentence.
And this isn't just some theory from a textbook. This is how pros work. Listen to this from Jackson Gabbard, an engineer over at Facebook. He says that for an engineer, breaking down big problems into smaller parts is so core to what they do that it just becomes instinctual. You know, when they're trying to solve something huge, like making an app run faster, they don't see this one giant fuzzy problem. They instinctively see all the little pieces and figure out which one they can fix.
So once you've broken the problem into pieces, the next skill is abstraction. This is the art of simplifying. It's all about looking at all those little pieces and deciding, okay, what actually matters here to solve this problem? And then, and this is the hard part, having the discipline to ignore everything else. It's like finding the signal in all the noise.
And this way of thinking? It's been around for a long time. I mean, go all the way back to the 1800s. There was this woman, Ada Lovelace, who was looking at this calculating machine. Basically a fancy machine for adding numbers. But she did this incredible act of abstraction. She ignored the gears, she ignored the math, and she focused on the potential. She had this amazing insight. If a machine can manipulate numbers, she realized, it can manipulate anything that numbers can represent, like patterns or art or even music. That leap of imagination, that act of abstraction, it changed everything.
So, okay, we've got this simple blueprint and this powerful way of thinking. The big question is, where is all this taking us? What's next?
Well, check out this vision from Francesca Rosella, who co-founded a company called Qt Circuit. She imagines a future where the computers we know today, the boxes on our desks, the rectangles in our pockets, they just disappear, vanish. And instead, all of that same power will be literally woven into the fabric of our lives, even into our clothes.
And you don't even have to look that far into the future. You can see the beginnings of it right now. Think about the AI that powers those chatbots. It seems like magic, but it's just a huge, complicated version of input, process, output. Your question is the input, the AI's giant language model is the process, and the answer it spits out is the output. Or think about augmented reality glasses. That's just a super creative new way to handle that output step, right? Blending the digital right onto the real world. None of these things are magic, they're just really, really clever applications of the same basic ideas we've been talking about.
So let's bring it all back. That simple blueprint, input, process, output, and that problem-solving mindset, breaking things down and focusing on what matters. These are not just techie terms for a quiz. No way. These are practical, powerful tools. They give you the keys to the kingdom, not just to understand the world we're living in right now, but to actually get in there and help build the world of tomorrow. And that's a real superpower.
So, I'm going to leave you with a challenge, a question to think about. Forget about coding, forget about being a tech genius for a second. Just think about your own life, a project at work, a personal goal you're trying to hit, heck, even just planning a big family vacation. What's one problem you're dealing with right now that you could attack differently if you just started by breaking it down into smaller pieces and then focusing only on what truly matters? Give it a shot. You might be amazed at what you can solve.